Next, we will define equivalence relation. We have defined that relation in set A is subset of Cartesian product A cross A. So if element A is related with B under relation R, then we write AB belongs to R, and we write it as A is related with B. So first we define a relation called reflexive relation. If A is the element of A and every element of A is related with itself under the relation R, then this is called reflexive relation. Second is symmetric relation. If elements A, B belongs to set A and under relation R, A is related with B, implies that B is related with A. This implies that relation is symmetric. Third is transitive relation. If A, B, C are three elements of set A and under relation R, A is related with B, B is related with C, this implies that A is related with C, then we say relation is transitive. And a relation which is reflexive, symmetric and transitive called equivalence relation. For example, if we consider a set A, which is a set of parallel lines, we take three lines. One is A, another B, and third one is C, and these lines are parallel to each other. Here, A is related with A because a line is parallel to itself, hence reflexive. Second, here A is related with B because A is parallel to B, and also B is also related with A because B is also parallel to A. This implies that relation is symmetric. And third one, A is parallel to B, so we write A is related with B. B is parallel to C, so we write B is related with C. This implies that A and C are also parallel, so we write A is related with C, and relation is transitive. Because it have relations reflexive, symmetric and transitive, so the set has equivalence relation. Now we take another example where we have a set of perpendicular lines. Say A is a set of perpendicular lines. Suppose this is the line A. Another line which is perpendicular to A is B, and third line which is perpendicular to B is C. Here, if we check for reflexive relation, because line A is not the perpendicular to itself, so we say it is not reflexive. Second one, A is related with B because line A is perpendicular to line B. It has an angle 90 degree. This implies that B is also related with A because B will be perpendicular to A. So relation is symmetric. Third one, here if we see A is perpendicular to B, so A is related with B. B is perpendicular to C, again B has relation with C. This implies that here if we check A and C, now A and C are not perpendicular but parallel. So we say A is not related to C. That means relation is not transitive. This implies that equivalence, it is not a equivalence relation. So a relation may be reflexive only, may be symmetric only, may be transitive only, or a combination of that. If a relation is reflexive, symmetric as well as transitive, then we will say it is a equivalence relation. As we have already discussed that if number of elements in the set A are n, then number of elements in Cartesian product of set A with itself will be equal to n into n, that is equal to n square, and number of elements in relation from A to B will be equal to 2 raised to the power n square. Similarly, number of reflexive relations will be equal to 2 raised to the power n square minus n, which we have to remember. Here for n equal to 0, number of reflexive relation will be 1. For n equal to 1, number of reflexive relations is again 1. N equal to 2, we will put here 2, it will be 4, and so on. Number of symmetric relations will be equal to 2 raised to the power n square plus n by 2. There is no direct formula to find the transitive relation. So it have to calculate it manually, no formula. So if we have find some data about the number of reflexive, symmetric and transitive relations, we take some initial elements. Number of elements are say 0 in a set A, 1, 2, 3, 4. Then number of reflexive relations will be 1, 1, 4, 64 and 4096 using the formula that 2 raised to the power n square minus n. Number of symmetric relations will be equal to 1, 2, 8, 64, 1024 using the formula 2 raised to the power n square plus n by 2. And number of transitive relations will be equal to 1, 2, 13, 171 and 3994. And number of equivalence relations will be equal to, if number of elements is 1 is 1, if number of elements in the set A is 1, then it is 1, 2, for number of elements 3 it is 5, and for number of elements in set A 4 it is 15.